change the connection also. Wait for a moment. Okay, so I hope the screen is visible and I am audible too. Okay, so what I am trying to cover today, let me just first give you a quick idea, is that we will discuss a little basics of GNSS in terms of its introduction. Okay, I mean, let us just forget for the time being all the theories that you have read about GNSS till date. Just let's start fresh, because what happens, people have a little or blurred idea about GPS and GNSS before attending this class, and they cannot overcome it. So what will happen when we start afresh? Your mind should grasp enough content that you are reading right now. So do not think that what you have read is wrong or right. Just think that we are starting afresh. Whatever concept I am learning, that should be there in my mind throughout my life. And in introduction, we will see how the history of navigation system works. Okay. I mean, what were the previous navigation system? Then, since we know that GPS is developed by United States, so GPS is not one product that came just out of the box. It has a process. So that process started with transit, then timation, then Navstar GPS. So we'll see one by one, and then we'll quickly see about GPS segment. What are the three popular segment that you should focus on? You should remember, and obviously the status, present status, as well as the advantages and limitations. I hope it is clearly visible to all of you. Let us just see one by one. So you have second slide as history of navigation system. These slides are, the notes of Professor Onkar Dikshit at IIT Kanpur. So, we were following right from the very beginning because we were given these notes in our post-graduation days. Okay. So, history of navigation system is something which is started with the Stone Age, and now you know, because you must have seen in many of the old movies or in old some documentaries that people use the big mountains, trees, and stones, big set of stones, to use their point of reference. So when they were going on a certain path, they try to mark on that big stones so that they do not forget when they were have to, they have to move back. They should not go on a wrong direction. Okay, so that were the Stone Age. Okay, then the age came of the Star Age, or Galileo, at the time when the Galileo started exploring these stars. So that were the Star Age, and this is the celestial navigation, we call it. Okay. uh, so in that case, what we are uh, thinking of taking the reference from, these stars, and the point of reference were sun, moon, and the stars. Now here, what is important point is that you are reading the point of reference first, isn't it? The point of reference is uh, that this is what we need if we want to navigate from one point to another, isn't it? So obviously the point of reference will change as we move on to more technological advanced segment. So initially point of reference were stones, then point of reference were sun, and now with the radio age, or so-called radio signals, we have satellite age, where we were working with satellite-based radio navigation, and point of reference were satellite. Now you must be thinking in this satellite age, when the point of reference were satellites, then how we are communicating, isn't it? So that is what I'm saying, the satellite based radio navigation. Now I'm asking one question. It's a very good important question to all of you. Since you have read your first semester and you all have secured good grades, A plus, A, and so on, why the communication or navigation system relied on radio wave band? Why not some other waveband? Why the in EMR spectrum, you must have seen all the spectrum, but why in the satellite age it depends on radio navigation, radio based navigation? And I want answer from your side. क्या भाई सन्नाटा क्यों छाया हुआ है?
Hello, sir.
हाँ, बताओ बताओ।
Sir, because radio wave have a very large wavelength as compared to other spectrum.
चलो ठीक है, उससे
Sir, so it will travel more distance,
it will travel।
rather than other
चलो
waves.
डिस्टेंस ट्रेवल का तो एक कॉन्सेप्ट समझ में आ गया, अब उसके अलावा?
Sir, radio waves are transmitted easily through air.
थ्रू एयर?
Yes, sir.
ऐसा किसने कह दिया? लेकिन यहाँ तो एयर बहुत बाद में आएगी। आपकी सैटेलाइट कहाँ पर है? 20,000 किलोमीटर अवे फ्रॉम यू, वहां तो एयर भी नहीं है।
सर ह्यूमन बींग्स को हार्म नहीं करती है इसलिए भी।
ये कोई सही आंसर नहीं, टेक्निकल आंसर दीजिए आप तो। सोशल आंसर दे रहे हैं। इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम अपने सामने उसकी इमेज ओपन करिए। देखिए, ये मान के चलिए, मैं आप सभी लोग बता रहा हूँ, भले आप लोगों ने रिमोट सेंसिंग का कोर्स पढ़ लिया, अच्छे ग्रेड आ गए, लेकिन मैक्सिमम क्वेश्चन इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम पे होते हैं, और वो स्पेक्ट्रम की प्रोफाइलिंग आपके सामने, जो भी इस फील्ड में कंटिन्यू करना चाहता है आगे, वो अपने दिमाग में वो स्पेक्ट्रम की प्रोफाइल बना ले। ट्रीज के लिए, वाटर के लिए, जो डिफरेंट डिफरेंट स्ट्रक्चर्स हैं उनके लिए, ताकि आपसे कोई भी अगर क्वेरी पूछी जाए कि विजिबल बैंड की क्या प्रॉपर्टीज है, रेडियो बैंड की क्या प्रॉपर्टीज है, माइक्रोवेव बैंड की क्या प्रॉपर्टीज हैं, आपके दिमाग में सबसे पहले वो इमेज आनी चाहिए, जो सारी वेव बैंड्स एक ही जगह पे होते हैं। अभी इसका सबसे जबरदस्त आंसर तो ये है कि एटमॉस्फेरिक विंडो बहुत जबरदस्त मिलती है। It is independent, this radio wave band or microwave band, specifically from 1 millimeter to 1 meter kind of range. This is particularly free from atmospheric disturbances. एक अच्छी विंडो मिलती है, और रिमोट सेंसिंग वहीं पॉसिबल होती है जहां पर विंडो अच्छी मिलती है। तो आपके आंसर थोड़ा सा टेक्निकल कब झुकेंगे? जब आपके सामने इमेज अच्छी बनेगी। आप लोग क्या है, अभी आप लोग बुक नहीं पढ़ रहे हैं। जब आप लोग बुक ज्यादा पढ़ेंगे तो आपका माइंड ओपन अप होगा। रिमोट सेंसिंग में जैसे जैसे सिचुएशन बदल रही है, the more advanced techniques are coming up, the more sophisticated instrumentation is coming up. Remote sensing is just revolutionized हो रही है. You just imagine कि 1980s में भी remote sensing होती थी और 2022 में भी हो रही है. It is one such technique which cannot be vanished. पहले space agency could have only 1 or 2 satellite mission. Nowadays every space agency is having 15-20 missions. Just imagine. So develop your knowledge from reading so that you should understand the application orientation of individual technique. Okay, आप लोग क्या है, बहुत बुकिश नहीं है अभी. यू आर जस्ट, जैसे आजकल स्लाइड शो होते हैं ना, बुलेट पॉइंट्स, आप लोग वही बोल के चुप हो जाते हो. You need to read more. Okay, you should read that much that you should give us back the knowledge. I mean, we want that we should also garner some new knowledge from your side. Chaliye. So these are the 4 ages. I hope it is very clear. There's nothing rocket science in that. There is one radio navigation system. There is one table. That table I'll focus on. So radio navigation system by Decca, then GEE, then LORAN A, then LORAN C, then Omega. These are the radio-based navigation system. Okay, where frequency, low frequency, hyperbolic navigation system, very high frequency used, the 1850 kilohertz, 1950 kilohertz radio band used. Then LoRa C has 100 kilohertz, and then Omega is very low frequency, 10 to 14 kilohertz, developed by these different agencies. Now, what the working principle is little more important. That Decca comparing the phase difference of radio signals, measurement of time difference between the reception of pulse from the ground transmitter. LORAN A is phase comparison. LORAN C is phase comparison. Now, when I say phase comparison, what do you mean by phase comparison? Let us just discuss this. What is more important in the phase comparison is that you must have gone through the Shannon-Fano algorithm in your BTech first semester, where when you read about IT. And in that IT background, you have heard about the modulation technique. And there are 3 types of modulation, isn't it? Frequency-based modulation, amplitude-based modulation, and phase-based modulation. We have written several equations also, isn't it? So every wave have this phase characteristic associated with it, because it's a long wavelength, it will have a phase. So when it contains this phase information, people try to explore this also apart from this so-called wavelength and frequency. So the objective of understanding this so-called comparison or using these properties is that, can we go from low precision to higher precision by using any of these properties? So the precision, the term which we have studied in the previous semester, focused on the how well we can have the least count, isn't it? Suppose you have a scale that measures only graduation in meters. Then you have new scale which measures the graduation in centimeter. Then the new scale which measures in the millimeter. Then the new scale which measures in the up to 4 decimal. So obviously, the more your least count improves, the more your precision improves. Similar concept is applied on the waves also. Can we use frequency information? Can we use phase information? Can we use amplitude information for different purposes? But which would give us more precision in our answer? आप लोग कभी देखेंगे कि the moment you tune on this 92.7, 93.5 or whatever, they are all megahertz. आपको क्या बोलते हैं? Tune into 92.7 megahertz big FM. Now, can your is it possible that your ears can listen this 92.7 megahertz? Absolutely not. Your ear are not capable for that. But the information, the song, which is a very low frequency data set, they are modulated over these frequencies and they are transmitted to you, and these transmitted is received by your mobile or devices, and then they demodulate the song and you listen, but this process is so fast. Okay. Similarly, where do we use amplitude modulation, where do you use frequency modulation, where do you use phase modulation? You just note it on your notebook that this question is being asked: where do we use amplitude modulation, where do we use frequency modulation and phase modulation? And you just explore this concept, because it may be asked to you in any of the interview or any of the viva, that what will happen if we use amplitude of modulation in place of frequency modulation, etc. So you just understand that you have a wave that has these properties. You have a wave that has a magnitude, or which we call it as amplitude. Then this wave has a frequency, and then this wave has a phase also. A sine omega t plus phi. This is what we write as a wave. A cos omega t plus phi. These are the wave's signature. How do we write it? Okay. Omega represents the periodicity, and the phi represents the phase. A represents the magnitude. So you need to think, sorry, omega represents the frequency, T represents the periodicity. So you need to consider the properties of the waves, how they are represented. Do you know that during your JE preparation, you must have gone through the complex number, isn't it? And it's a very popular topic, and usually people do not cover that in detail. I don't know why, but believe me, your radio band, this theory is purely complex number, e to the power I theta. That's it. Your start with this. Your equation starts with this, and then this whole radar domain, where now people call it SAR, INSAR, MT INSAR. This whole domain is started from this very little complex number. So those who know the complex number, they can kill it anytime. And many people, those who understand this complex number, can solve many of the problems without even learning the algebra. So complex number is also one good concept that you should revise at this age. You should go back, try to see some good YouTube lectures and revise the complex number. If you are good in complex number, believe me, you would cover the whole radio waveband remote sensing. So that's one suggestion for all of you. Okay, so in satellite age, we overcame limitation of the radio navigation, improved radio transmitters, wider coverage, satellite orbits at higher altitudes. Accuracy in computing positions depends on the accuracy in computing the location of reference points. Please remember this point. This fourth point I have discussed with you in one of the previous class, where I've told you that what you are doing, you are writing a distance equation. D12 is equal to square root x1 minus x2 square plus y1 minus y2 square plus z1 minus z2 square. In that, x1, y1, z1 are your location on the surface of Earth, and x2, y2, z2 are location of satellite in the same reference system. So this accuracy of satellite age depends on one major factor, that how well you are computing the satellite position. You will have one dedicated laboratory on computing the GPS satellite position. Do not miss that, because it's very good laboratory. Very simple MATLAB code, and you can compute it. So again, I'm saying that accuracy in computing position depends on the accuracy in computing the location of reference point. Okay. Then continuously monitoring of satellite location in their orbit. These are all the advantages I'm reading apart from this accuracy. That plus, but always remember, I mean, when somebody says, okay, how GPS operates, usually I ask this question in the PhD interviews that people apply here for PhD position, and I usually start with very basic question: can you explain me how GPS works? Because if you have read enough, if you have gone through the literature, you must know that how a GPS operates. So what are the prime component? So first you will say space resection principle. You can write it on your notes also. You just write a heading how GPS works. The principle is space resection. Space resection means you have satellites in the, because please remember, in any of the interview, if you do not answer the basic question, they will not never ask you the advanced questions. If you do not answer the basic, how come you answer the advanced questions? So I'm very you know with I'm very upset with several students, even of our MTech guys, that despite explaining it several times, they do not explain the basic concept of GPS working or remote sensing working or lidar working. Or despite we are having a good, I mean, we have a very good academic structure at par with IITs here, but still we are only a few students are coming out of that domain to contribute more and more in this field. So the reason is very simple, that you do not read, do not listen, do not revise, and that's the challenge that you are facing right now. So I'm answering the question on how GPS works. The principle is a space resection. How a resection works? You have satellite in the space which are acting as a control point. Okay, those control points. How can you say the satellite as a control point? Because the control segment knows the very precise position of the satellite in the orbits. Okay, if you know the satellite position in the orbit very precisely, you have a receiver in your hand that can compute the distance between you and the satellite based on the signal received. You have one observable, that is range between you and satellite. So you have three unknowns XYZ. You have to have three observable plus the satellite's position from three different satellite. Then you can write the unique equation. But the GPS system is also unique in the sense that it works with time, on close coordination with time. So you need four satellite to resolve the receiver clock error also. So you need four observable, minimum four observable to work in it. This is the basic simple principle. You can explain in pieces, bits and pieces. You can explain it very clearly, but you have to explain this, and that's how satellite A's works. So in satellite A's, you need to have the satellite positions or moving control points with very precise information. Okay, then obviously 24-hour all weather means, be it rain, be it snow, be it whatever it is, your GPS works. Many of the glaciers which are melting or moving, they are monitored by GPS. Other techniques fail sometime, but the SAR interferometry and GPS works. That's why it is very popular, and you must have heard about it, that ISRO and NASA have joined and have an integrated mission called NISAR, because that is the future. So historical development, we have Hiran, which is developed during World War II. We have inertial survey system, which requires vehicle truck to occupy a point of known coordinates and remain stationary for zero velocity update. Then we launched the Sputnik satellite in 1957. Then you have transit system. This US Navy transit system is also known as Navy Navigation Satellite System, NNSS, in 1967, commonly called transit. This launched the background for GPS. You must have seen, or you must have looked in one of the slide during when I was explaining WC84, that it is maintained with the help of stations which are having or observing the transit satellites, transit system satellites, isn't it? Why? Because transit system launched way early, 1967. Then comes obviously the GPS, but that GPS is also known as Navstar GPS. The full form of GPS is Navstar GPS, which is navigation system with time and ranging. It's very good, brief full form, navigation system with time and ranging. So in mid 80s, US Department of Defense began to implement a second generation satellite positioning system, and it's fully operational since 1994. So before 1994 comes the WS-84 1984. So that's why Transit helped in developing this WGS-84, which is a reference ellipsoid, and it contains several ground control points. Then the GLONASS, the similar version to GPS from USSR, then Galileo, Baidu from China, QZSS from Japan, and regional systems like us, IRNSS from India. Now it's time that you should start looking the chapter 1, which I've sent in the previous class, chapter 1 and chapter 2. So this time you can quickly start with chapter 1, because it's all historical development and you should read it. At least once you should read it. I'll be writing or framing questions from that chapter itself. Okay, it's a good chapter. I also want to read it in one go. Okay, so various satellite systems. So one by one: Transit by US Navy, Timation by US Navy, Secor by US Army, Navistar GPS from Department of Defense USA, GLONASS from Russia, and then these are not popular, or rather less used. Then Galileo, Compass, and Gagan. Gagan I'll explain later on. Gagan and IRNSS are different things. Many people are all time confused with these two terms. Gagan is a different thing. IRNSS or Navic is a different thing. Okay, so please don't get confused. I'll discuss when the time comes. Gagan is a different thing. Okay, so QZSS is from Japan. Again, this one slide, you just try to grasp by yourself. So I hope you have seen this. There's nothing. It is US satellite navigation systems are explained. So you have transit, timation. You just need to at least read once. There is no recommendation for memorizing everything regarding these systems apart from Navistar, because you will read enough about it. But what is expected is that you should at least go through once and try to focus on the key aspect. Okay. So you have transit, 7 satellites launched in 1960, available to civilian user 1967. There were only 7 satellites. Timation, Naval Research Laboratory, NRL, only 2 satellites, 1967, primarily for ship navigation. Shekor, US Army Satellite Navigation, 13 satellite, 1964, 1969. And then they all merged the above three in Navistar, and it was organized by Joint Program Office, Department of Defense, with Block 111, Block 2nd 28, Block 2nd R21. So Block 1, 11 satellite were launched. Block 10 or second A, 28 were launched, and then advance or replenishment, some were failed. At present, no Block 1 satellite is running, so it is replaced completely, and now the Block 3rd is going on. Okay, so transit, again, purpose was to look for ballistic missile in submarines, navigation, sea and air traffic, surveying hydrographic and geodetic. Launched on 1960 April 13. 51-degree inclination orbit, low polar orbits, altitude of 1100 kilometer only. That's why focused only on US region. Apogee 745, perigee 373. What is apogee and perigee? Perigee is the nearer point of the satellite from the Earth. Apogee is the farthest point of the satellite from the Earth, being Earth at a foci of this elliptical orbit. The orbital period is about of 106. Quite fast, isn't it? 106 second means less than 2 hours. In less than 2 hours, it will revisit again the same area. So it's quite fast, but being in the so-called lower orbit, it's possible. Satellite broadcasted ephemeris information. What do you mean by satellites? You know, broadcast means, that means something is broadcasted to user. What do you mean by ephemeris? Ephemeris is a Latin word, Greek word for orbital information. So it's just like whenever you are roaming around in the city here and there, your mother or father or parents calls you and ask you, where are you? And then you tell them, okay, I am at this place. It is just like this. Satellite are sending their ephemeris, just like you are telling your parents that I'm here. But they are quite precise, and unlike you, they inform the user very precisely where they are, and they continuously operate on 150 megahertz and 400 megahertz. They have Oscar and Nova satellite systems used uh, in the transit. Final constellation consisted of 6 satellites, 3 ground control stations, and receiver. Please remember, this 3 ground control station is important to have for any kind of navigation satellite system. Why? Because they are the eyes and ears. Because for users, satellites are operating in a one-way system. They are only transmitting you. Just like you see, when you open your mobile phone and you switch on your GPS, do you send anything to signal? No. It is you only receiving it. It is a one-way system. But to operate that one-way system, you need somewhere few systems that have two-way communication. That means they could also talk to satellite, listen to their problems. So these are the ground control points. Three ground control points are there that talks with the satellite. Okay. The last transit satellite launched happened in 1988 and transit program ended in 1966. Once the GPS becomes fully operational, the limitation of transit, incapable of providing continuous navigation data in real time on a global basis, limited coverage, unavailability period lasts from 35 to 100 minutes. Inherently two-dimensional, because to operate three-dimensional you need data from three satellite, but at a time it is not available three satellite. How can you work with the three-dimensional? Velocity sensitive, it means there must be some mechanism by which it is sensitive to velocity. Velocity means the satellite velocity. Timation, developed in 1972 by NRL Naval Research Laboratory, kept into improved from near polar to little circular orbit, 70-degree inclination circular orbit, altitude 900 kilometer. Timation satellite intended to provide time and frequency transfer. Original satellite flew with stable quartz oscillators. Later models, first space-borne atomic clocks. Timation program was merged with transit and GPS programs. Okay. So, anyways, the transit and timation you should remember. You should also remember that they are low Earth orbit satellites, unlike GPS. The limitations were quite similar, like transit, that they are not providing global coverage. Their, you know, so-called unavailability period is quite large. So they were certain setbacks that these kind of satellite system cannot be used on global purpose. It means that the full form of GPS is global positioning system. Okay. Many a times a student read too much, that sometimes when people ask what is the full form of GPS, they said geographical positioning system. It's quite wrong. And it's happening right in the PhD or MTech Viva, that people do not know the full form of GPS. It is global positioning system. You should write it in your notebook. Global positioning system. What is the full form of GNSS? Global navigation satellite system. Okay. Moving ahead, here comes the Navstar GPS. So I guess screen is visible. It is mandatory for all of you to read each point very carefully. I'm just giving you 5 minutes to read it so that we can discuss one by one. Any questions up till then? I mean, apart from this satellite, if you have any questions, we can discuss once again before we start this Navistar GPS segment. Any question, any silly questions if you have. Hello.
हाँ सर, जो अभी आपने बताया कि सैटेलाइट को सर रेफरेंस पॉइंट मानते हैं,
हाँ बोलिए बोलिए, सुन रहे हैं, आवाज पूरी कंप्लीट करिए सेंटेंस।
तो मतलब सर सैटेलाइट तो सर मूव करती रह मतलब अब ऑर्बिट में से मूव करती रहती है, तो सर रेफरेंस पॉइंट चेंज नहीं होता सर उसका।
और किसी का ऐसा सिमिलर क्वेश्चन है? देखिए बहुत बेसिक क्वेश्चन है और कोई दिक्कत नहीं है, ऐसे क्वेश्चंस होने चाहिए। अब मुझे ये बताइए कि और किसी के कोई क्वेश्चन, सेम सेम क्वेश्चन किसी दूसरे फॉर्म में, कोई दूसरा क्वेरी एसोसिएटेड हो सिमिलर क्वेश्चन में। आलोक,
यस सर।
बताइए जो इन्होंने पूछा है उसका क्या जवाब होगा। क्यों भाई,
सर
तो आपने क्यों नहीं पूछा? अगर आपको नहीं आता है तो क्यों नहीं पूछा? हाँ भाई, देखिए क्वेश्चन बहुत सिंपल है। इन्होंने पूछा कि सर वो पॉइंट ऑफ रेफरेंस है बदल नहीं जाएगा, isn't it? The position of the satellite in the orbit is changing because satellite is moving at a speed of 4 kilometer per second. Can you imagine? Satellite in 1 second is 4 kilometer away from its previous position, isn't it? So what happens is that satellite has its trajectory predefined. Satellite who's moving in this orbit has its trajectory predefined. Who defines the trajectory? It is defined with the help of control segment. I'll discuss what is the role of control segment, but as if I have given you the coordinates which you have to reach in the time to come. Okay, so when satellite reach at that point in real time, and if there is any deviation in that point, that is properly recorded, modeled, and an error is to be found out. How, what is the reason the satellite has not reached that same coordinate? Okay, so the objective is very simple, that satellite itself informs to control segment that these are my trajectory coordinates, these are my parameters of the orbit which I am following right now, and if there is any deviation from that trajectory, control segment updates to that same satellite. Otherwise, if it is okay, they move ahead. So it is something like, it is a log file which they have to follow at every second. So the moment they reach at any position and they continuously transmit the signal, so within that millisecond or microth second, their position is defined, their position is fixed, that their position in this orbit is this. So when they transmit, they do not send directly the coordinates, they transmit the orbital parameters. Now you must have seen several parameters in your 11th level physics when you read about the Kepler's rule, when you read about the escape velocity. You have read all these. So at that time, what are the parameters that defines a orbit are properly accounted, logged, and a report file or kind of file is prepared. Okay. So when I say point of reference is satellite, or when I say point of reference is control point, that means their position at every epoch, or when I say epoch, that means at every instance when it is transmitting the signal, the position of the satellite is well known in millimeter level. And that's why this GPS operates at millimeter level, because your satellite position is available in millimeter. Shivam, is it clear to you?
Yes, sir. Thank you, sir.
Any other question before we start this? Okay, so let us quickly see the Navistar GPS objectives one by one. Suitable for different platform, aircraft, ship, land-based, space, and now on mobile. You have it. You must know that this is one technique which is still under use. We are using only 5% or 10% of GPS potential. Very huge research area is still pending where you can use GPS. You just think of it, you can use it. Nowadays, these drone mapping is possible because of GPS. Bloody lot in last 6 years, people were talking about the drone-based mapping, but because they do not have that RTK accuracy for UAV position, so that's why they could not do it. But nowadays, every small vendor is doing drone-based mapping, and their topographical mapping accuracy is quite high. You can read it, any article you can search that a topographical survey using UAV, and its accuracy measures. You can see it. It is of the survey grade quality because of the GPS. You have GPS on the ground, you have GPS on over the UAV, you can do wonders. This is the future, and we are just employing these nowadays. Able to handle a wide variety of dynamics, rapid time, real time positioning, velocity, and time generation, time determination capability to an appropriate accuracy. You can, as I've told you, there is a one single center in the Delhi which measures only time and frequency based on the GPS and hydrogen measures, because it's accurate. Positioning results available on a single global geodetic datum, which we call it as Earth Center Earth Fixed Geodetic System, reference system. Highest accuracy to be restricted to a certain class of authorized user like military. Resistant to jamming. No other third party can jam it because it is encrypted in nature. The signal is encrypted. If you see the signal, it's a noise. Only authorized user can access to it. Redundancy provision to ensure survivability of the system. Passive positioning system that does not require transmission of signal from user to satellite. Low cost and low power, and therefore highly complex satellite segment, total replacement of transit satellite and other terrestrial navigation aid systems. So these were the design objective. They are documented. The details is US Air Force conducted concept studies for three-dimensional navigation system called 621B. US Navy Timation, US Air Force 621B 3D constitutes the NavStar. The full form is Navigation Satellite Timing and Ranging, or GPS. NavStar GPS, a satellite-based first component. What are the inherent component of GPS? If somebody asks, what are the inherent component of GPS? It is satellite-based. It is radio-based. It is radio positioning. It is time positioning and time transfer system, designed, financed, deployed, and operated by US Department of Defense. Satellite based because it has satellite. How many? I'll discuss it. Radio based because it operates in that radio waveband. Radio positioning, you are using the radio signal to position yourself. And time positioning because every signal is time stamped. And time transfer system, you work from GPS to UTC. अगर आपसे मैं कहूं मैं जीपीएस टाइम में वर्क कर रहा हूं, किसी सामने वाले को पता चलेगा? No, nobody knows what is GPS time, but everybody knows the UTC, the time in your clock. Right now it is the UTC time. Okay, so designed to take over from existing navigation system, to be supplied to each man in field and installed in all military vehicles. First and foremost, a defense system developed by US Department of Defense as a military system to provide worldwide coverage 24 hours per day, low end user cost, 10-20 meter accurate navigation position. So when it was conceptualized, nowadays you even track your accuracy within a meter in your mobile phones, because the coverage of previously you were working with the help of GPRS network, but nowadays mobile itself has a chip, and you can download the Rhinex file from your mobile. I'll share the app to you if your mobile is high graded and it has a GPS chip inside, which obviously has if you have a smartphone, good recent smartphone. You can install one app and you can download the Rhinex file. So the availability of satellite is better. User can have a better accuracy. Civilian accuracy is better. Okay. First test signal from space were transmitted from navigation test satellite 2, launched in June 77. First NavStar satellite launched in 1978, and system was declared fully operational in 1993. That means between 1978 to 1993, a series of satellites were launched, and a total of 11 satellites were launched in Block 1. Most advanced real-time positioning technique based on transmitting a coded satellite message. It's a very good line, very important line, very important line in the sense that you could understand the whole concept. Just read it. So your GPS is a most advanced real-time positioning technique based on transmitting a coded satellite message which could be received by a ground portable receiving unit, which we call it GPS receiver. So you are working with the receiver that has capability to receive this coded satellite message, which is coming in the radio waveband. We'll discuss in detail. I mean, at present I'm not opening up everything so that it should not be confusing. At this point you should only remember that it is radio based communication system, isn't it? And you are getting a coded message. We'll discuss what are the code message. We'll discuss the encryption involved, how they are encrypted, what is the encryption mechanism. We'll discuss everything. But at this time, the summary is in front of you. The principle I have explained, the background I have explained. Now this is the summary. The real-time positioning techniques based on transmitting a coded satellite message, which could be perceived, or sorry, which could be received by a ground portable receiving unit. Requires minimum 4 satellite, three for 3D position, 1 to keep track of time information. Typical GPS receiver. This is very important point. Typical GPS receiver consists of user, consists of antenna, radio receiving unit mounted on a tripod, power supply source, oscillator, internal clock, mini computer. Nowadays it's so much easy that you in your hand you have a GPS grade receiver. We have handheld receiver. We will have one lab also, Juno 3B, that will be given to you. You could understand that also. Okay, so you have antenna, you have power supply source. I'm just looking for one good figure so that we could show you also. Nowadays you are having chips. I mean, I mean, last 10 years things are so modern that you are having a chip of $2, $3, $5. You can purchase it online nowadays. Let me share one figure. I hope it is visible to you. So this is the antenna. This is little wire is the radio modem for transferring, and this is the tripod on which it is, or bipod it is, over which it is standing. This is one another good figure. It is a receiver. It is a this pole carbon fiber rod. There is another figure. This is a high grade antenna. This is tripod. The wires are coming attached in bottom. Okay, so these are the certain examples of, this is one good example for antenna, the choke ring antenna. This is one choke ring antenna that is established. Sometimes people get confused where we are getting the point. So point is always is the ground over which this is centered. So we are getting the position for this point, not for this point. Please remember, whenever you install a GPS, you install over a point. Suppose this is the point over which this tripod is centered, or let's say better figure for tripod, let's say this is so let's say this tripod is centered over somewhere this point, isn't it? So this tripod has a center at this point, so GPS receiver is giving the location for this particular point. Please remember, always it is not of the here, it is on the ground of this point. Okay.
सर
Yes.
सर आपने अभी जितने भी पिक्चर्स दिखाए सब में जितने भी एंटीनास थे सब एकदम सिटी के बाहर आउटर जगह पे थे। ये
हाँ।
इसलिए कि सर नॉइस ना आए रिसीव करने में सिग्नल में, या और डिस्टरबेंस ना हो, ये इस वजह से है सर।
देखो, वर्क के हिसाब से फिगर डले हुए हैं। हमने तो बस सिंपली ऐसे गूगल सर्च करके आपको बताया कि आप भी गूगल सर्च करके देख सकते हैं सब चीजें, है ना। मैं आपको सिटी वाला दिखाता हूं जो हमारे आपके लेबोरेटरी में भी रखा हुआ है। ये देखिए, ये हमारे पास रिसीवर है ट्रिम्बल R10। दिस इज द हाईएस्ट अपग्रेडेड इंस्ट्रूमेंट अवेलेबल बाय ट्रिम्बल। ट्रिम्बल इज अ मैन्युफैक्चरर, and this instrument we have it. You are lucky that you have such kind of geodetic grade receivers with us. You have radio modem, it works with Wi-Fi, it has a base pair combination is with us. Such setup is available with us. You can work in cities, you can work in anywhere, whatever, wherever you want. These kind of studies are generally conducted for, what should I say, the tectonic crystal movement studies, tectonic movement studies, landslides, flood, all kind of, or let's say topographical survey for a larger area. So all these kind of studies are conducted. You can have this GPS position. Let's say a car is parked, you can incline your receiver and it is capable of providing the correction for this tilt also, which we have this type of receiver with us in our laboratory, which we have purchased in 2019, where if you are providing a tilt in your antenna, it is sensitive enough to know that how much tilt is there, and it can compensate for it. See these figures, see these figures. Such kind of data would be popular to have. Okay. So Navstar has three component. One is space component, another is control segment, another is user segment. You just see, this is space segment where you have satellites in the space. Then you have control segment, which is working in a two-way communication. Here you see the two arrows. It is a two-way communication between space segment and control segment. But here with the user, you have single arrow. User do not contact the satellite. This is a very good point. People forget this point. So space segment is working in a close coordination with control segment. Space segment do not contact the user segment, it only transmit the signal. And nowadays if you have receiver, you just open up your mobile phone and go in the outside, you just need open sky, you can switch on your receiver, you will get the data. Signals are coming randomly every time. It means signal, you are sitting with signals right now. You just have enough receiving device, that's it. So these are the
Sir,
three things. Yes.
sir, means if I turn off the GPS, it actually the satellite is still sending the signals. Like in mobile, uh, when you start the GPS, it actually get the signal, or it always send the signals to the mobile.
Hey, that's what I'm saying. You are getting the signals every time. You just need receiving unit.
Okay.
ठीक है? So this is the idea of having a control segment is that if something happens to the satellite and it lost contact, what who are the responsible people to take actions? Control segment job is just like us. As a researcher, people are sitting in the control segment. They are continuously monitoring the trajectory. They are continuously monitoring the orbital files. They are continuously monitoring the satellite clocks. When we discuss each and every space segment in the next class, you will be wondered that the atomic clocks are installed in the space satellite system. Your satellites, the GPS satellites have onboard atomic clocks, atomic standard clocks. That's why the cost of individual satellite is in $1 million. But your receiver, which nowadays I'm saying that it is $2, you have a chip. Do they have the onboard atomic clock? No, they are quartz clock. That's why they are improper. They are low or substandard accuracy they are providing in time information. But we need to correct for it. So gradually you will learn. There is no problem in it. At this point, you just go through the chapter 1, initial few pages, so that you brush up your mind, think about it, think in terms of visualizing it, watch some YouTube video, have an interest. Because when you develop your interest, then this subject you will enjoy, because there is nothing like you have covered all prerequisite in the previous semester. You do not need anything new. You just need to understand how it is working, how we are moving from A to B, B to C, C to D, etc. That's it. But you need to be connected. You need to read little theory. If you underline those questions which you do not understand, if you have any query, you simply just underline it, share your screen, ask it, sir, I'm not getting this point, what is it? This also motivates me to read more. Otherwise, what I'll say, okay, my previous 10-year experience is enough to teach a newcomer in GPS. But what I want is that you should also involve in a discussion, so that I should be forced for reading more and more. Okay, that's we should work as a space and control segment. We should work as a two-way segment. Otherwise, we would be working as a space and user segment. I am only speaking, you are only listening. That's it. We do not want that. Okay, anyways, today we'll end here, and tomorrow you'll have a dedicated laboratory again. I hope this first laboratory of transformation is over by now. Please submit your reports timely. I mean, just make it a habit that you submit your experiment report, the codes, and everything at once the laboratory is finished, so that we quickly discuss the next topic. Okay. Any questions?